All right, so now we are factoring trinomials where what we're going to have is this a out front is going to be anything other than 1. So it's not going to be like what we were doing last time. So when we factor these, we could try a little bit sort of that reverse FOIL method. We also have AC method. So we're going to kind of touch on both methods for you in case one clicks a little bit more. Personally, I like AC method because it's quick and easy. But like I said, it's not always a method that clicks. So going back to the idea of the reverse FOIL, we want to consider the following multiplication. So if I multiply these together, I'd have 2x plus 5x is going to give me this 10x squared. Then I would have this 2x times the 5x. Oh, sorry, this 2x times, which one? I'm trying to do FOIL the way everybody tells you first. Outer. Yeah, so 2x times 4 would be your 8x. Your 4 times 5x is 15x. And then you'd have your 3 times 4 is your 12. So we're still getting 2 numbers here. It's adding to this. The problem is that these 2 numbers are not factors of 12. So to reverse what we did, we look for 2 binomials whose product is this trinomial. The product of the first term must be 10x, and the product of the last term must be 12. So we're looking for 2 numbers that would give us those, like the numbers that would give us those 10s and give us those 12s, but it would also give those combinations of multiples that give us that 8 and that 15 there. So like I said, it's more of a guess and check method than anything. The product of the outside term plus the product of the inside term must give us that 23. So we're going to look at, in general, finding the answer is going to just involve some trial and error. We use the following method to help limit some of our trial. Try to fit this in here just right. There we go. So the FOIL method for factoring trinomials is we're going to factor out the largest common factor if one exists. That's the first thing to always look for. If you have a as something other than 1, is can I factor it out? So like that example where we had, it was a negative out there. So we had negative x squared, we factored out the negative. We want to find 2 terms whose product is going to give us that a on the x squared. Then we want to find 2 last terms whose product is going to be that c. So we're kind of looking for products of a and factors of a and factors of c. We're going to keep doing that. We're going to repeat 2 and 3 until the combination is going to give us that b on the inside. So example would be this one. So I need factors that give me 2. I need factors that give me 6. So we need this to be a positive 2. This needs to be a positive 6. This is a positive as well. I'm assuming I just need positive factors. So as long as everything's positive, all those factors are going to be positive. So we would have 1x here, 2x here. So I don't have a lot of choice there. It's just going to be sort of like this combination of the other 2 I'm going to have to work on. Okay, so I'm going to purposely do this wrong the first time. So let's say we put 6 here and we put 1 here. So we're going to try this out. I'm going to get 2x squared, and then we're going to get x. Then we're going to get 12x, and then we're going to get 6. So what we see is that, no, this did not work. I did not get the right factors. So you could try these 2 But before you do that, you always want to switch these two numbers and try again. So like I said, this wasn't great. We're not completely abandoning these factors yet. Before we even do that, we want to do this first. Well, what if we put, instead of 6 here, we put 1 here, and then we put the 6 here instead. So 1 times 1x plus 2x is going to be 2x squared. 1x times 6 is going to be 6x. 1x plus 2x is going to be 2x. And then 1x plus 6 is going to be 6. I thought my thing froze for a second. Okay. So at this point, we're saying, okay, this did not work either. At this point, then we were going to tackle the 2 and the 3. So like I said, you just want to make sure that you tried all the combinations of these points. So we had, like I said, the x and the 2x. Those we kept the same. It was just these two factors. We just switched them around, tried again, see if it worked. And it didn't. So let me erase all this. So this time we're going to change and we're going to use that 2 and 3. We'll put 2 here, we'll put 3 here. So we'll FOIL. And this time we see we got it right. So we used the points the other way, the 3 here and the 2 here. It probably wouldn't have worked. But always, like I said, do the points one way, flip them, try them again. Now that I did that, we see we do have a factor. We factored into x plus 2 and 2x plus 3. So still we're the same worksheets we're using before. Start on number 7. Attempt this one. So hint, there's a common factor. So look for that first. So you have 7, 8, and 9. So 9 is kind of that same situation we had before with the x squared, y squared, xy in the center. We have m squared, n squared, mn in the center. Just be more worried about the numbers and make sure that when you write your factors, you have those m's and n's in the correct places. Okay, so we got to try number 7. First thing to notice that each one of these numbers is divisible by 2. So I'm going to factor out 2 first. So I actually have 6x squared plus 7x plus 2. So this is what I want to factor. So I need factors of 6 and factors of 2, because that's that end and that's that end. And we want to figure out what combination is going to give me this 7x in the center. So once again, everything's positive. So I'm only going to worry about positive factors. 1 times 6 or 2 times 3. And here my choices are 1 and 2. Kind of similar we had before, it's just opposite ends. So we have no choice that our second set is going to be 1 and 2. I can't change that one. What I can change are these ones. So I'm going to do 1x plus 1 and 6x plus 2, and we'll see if it works. Like I said, I'm just doing this randomly. So I get 6x squared. I get 2x. I don't think it's going to work. I'm going to get 6x here, and then I'm going to get 2. So 6x squared plus 8x plus 2. Not quite there, because we want that 7 in the center. So I'm going to go back, and like I said, the 1 and the 2, we could flip those. I'm just going to really just focus on these first ones. I'm just going to put my 6x here and then my 1x here and try again. So 6x times x, 6x squared. 6x times 2 is going to be 12x. Yeah, I don't think it's going to work. 1 times x is going to be x, and then 1 times 2 is going to be 2. All right. So we figured out this is not going to work for us. So like I said, these ones are fixed for the second part. So we're going to try the 2 and the 3 now. All right, so let's put 2 here, 3 here. So 2x times 3x, 6x squared. 2x times 2, 4x. 1 times 3x is 3x. 1 times 2 is 2. So I'm going to get 6x squared plus 7x plus 2. So I got this part factored. So if I was to completely factor this, let's do this in black. We'd have the 2 out front, and then we would have these factors: 2x plus 1 and 3x plus 2. I'll do us a favor, I'm going to write it up here. Okay. So this one, there's nothing common I can factor out, so I need factors of 7. And I need factors of -12, because I'm just concerned with the ends. So 7, it's either going to be, so not everything here is a positive. So just take that in mind. So you have choice of 1 and 7 for 7, -1 and -7 for 7. We need a -12, so our choices are 1 and -12, -1 and +12, or it could be 3 and -4, or -3. I missed one here. Wrote that backwards just a second. -3 and +4. I forgot my 2 and 6. Could be 2 and -6, or it could be -2 and +6. So this one we might be working on for quite a while. And it's reasons like this that I prefer AC method. So let's try factors of the first term just being 1 and 7x, 1x and 7x. And then we're going to play with the other 2. All right, we can try the first set. So 1 and -12. So we FOIL this, 7x squared minus 12x, which is already leading me to think this is not going to work. Then distribute this across, we would have a plus 7x, and a -12. Let me see, 1, 2, 3, 4, 5, -5x minus 12. So that one didn't work. So if we switch those last 2 numbers, so if we put the 12 here, or sorry, the -12 here, and then the 1 here, let's see, we're going to get 7x squared plus x. Then negative 12 times 7. That's going to be 4, 1, negative 84x minus 12. This is already looking way out of hand here. I think probably without finishing this, we know this is not going to work. Second, I just want to check something here. Okay. Okay, so we've eliminated a set here. This doesn't seem to be working. I'm a little hesitant to try these two as well because the 1 and 12 already weren't working. Okay, so I just want to solve this quickly. So as you can see, this could be very time consuming because then I have to try this pair. These ones don't work either. So it's one of these combinations here that's going to work for us. So as you see, before I even got to this point, I could have went through like 4 different versions of this, and then I would have to keep switching these points just to make sure everything was working. So we are going to try the 2 and the negative 6. Oops. Yeah, let's do 2 here and negative 6 here. So x times 7x, x squared, x times negative 6, negative 6x, 2 times 7, well, that's 14x. And then 2 times negative 6 is negative 12. So negative 6 plus a positive 14. Well, that is an 8x. So like I was saying, you may, I don't know how many versions of you would have gotten through, but you could have gone through several versions here, like 1, 2, 3, 4, 5 of these, and then just switching of the points before you even got to these are the pairs that you need. So this would be the factorization. All right, and this one again, because you have the m squared, make sure that the beginning of each binomial starts with an m, and then the n squared, the beginning of each binomial, the end of each binomial ends with an n. So you have an m turn and an n turn in each factor. So 18, that could be 1 and 18. That could be 2 and 9. That could be 3 and 6. Yep, that can be it. And then there's the negative versions as well. And then 12, you have 1 and negative 12, because one of these has to be negative. Negative 1 and positive 12. You could have 2 and negative 6. You could have negative 6 and positive 6. You could have, oh, where am I? 3 and negative 4. You could have negative 3 and positive 4. You see, like, we have a big list of these once again. So you could guess and check your way through it if you wanted to. I'm going to, like I said, this in this case, you would have, let me see, 1, 2, 3, 4, 5, 6, 7. Let me see. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 24. There's 24 versions of this. It might be more than that. 24. Yeah, I think there's 48 versions of these factors that you could use to guess and check your way to this. So I'm going to do a little cheating and I'm going to tell you what those are. Okay. So actually, I don't have to consider these. I know that the first one will at least be a 2 and a 9. And then the other set are going to be one of these sets with go 3 and 4. I was trying to find my numbers again. So just cut down a bunch of work for us. It's going to be one of these combinations. So like I said, we're just going to keep trying combinations until we get it. But as you saw there, like this could be quite a bit of work. So I'm going to do the 3n minus 4 first. So we're going to get 18m squared. We do the outers, then we get negative 8mn. We do the inners, we're going to get plus 27mn. We do the outers, we get minus 12n squared. I think I picked the first one the first time. So 27 minus 8 is going to be, oh no, I didn't get it. It's going to be plus 19mn. So at that point, I'm close. What it's suggesting to me is that I don't need to flip these 2 points because I'm getting the numbers I want. I'm just getting the wrong sign. So what I need to do is use this pair of negative 3 and 4. So I don't want different quantities. I just want a different sign. So I'm going to cut out this one. We're going to try this. So 2 times 9m is 18m squared. 2m plus 4n is plus 8mn. Then we're going to do negative 3 times negative 3n times 9m, negative 27mn. Negative 3n times negative 4n is 12n squared. Now we're getting our 19. That's n. Yes. And to tell you how I did this quicker, I actually use this other method that we're going to see here soon enough.